All right, these are notes number 18, our first notes for the week. I might go a little bit quick, so as always, remember pause as needed and copy down what you need to. This part should all be written down already from the warm-up in class. Remember to write your name, date, and period, and always have your 3 questions on the left and a summary at the end to get your full points. So this is 6-3 from our book. It's about similar triangles. So similar is different than congruent. We're learning how to use similarity theorems to find missing measurements. So we'll go through 3 different similarity theorems that can prove two triangles are similar. And once we know that they are similar, we can find a missing side if needed. Okay, so we should have the warm-up done already. So here's the first part for the notes. Okay, so again, pause as needed so you can copy. I'm just going to keep going. So it says we can show that triangles are similar when you know the relationship between only 2 or 3 pairs of corresponding parts. Corresponding parts could be angles or sides. So here's our first one, postulate 17, angle, angle, similarity. And we'll write it like this on homeworks and in notes, AA, and then this little squiggly line is a similarity. It's the symbol for similarity. So what this postulate says is if 2 angles of one triangle are congruent to 2 angles of another triangle, then they are similar. So we can say 2 triangles are similar if just 2 angles are similar, or sorry, if 2 angles are congruent. I'm going to highlight that because that is a very important thing. 2 angles are congruent to 2 angles of another triangle. So here we have the diagram. Again, just do your best to draw. It doesn't have to be perfect. You can tell these triangles are not congruent. They are not the same size. However, they do have the same shape. So they have the same 2 angles. You can see they're marked congruent, one arc at S and one arc at M, 2 arcs at R, and 2 arcs at L. So they have 2 congruent angles, so therefore the triangles are similar. We would know that angle T and angle P have to equal each other. Since the 3 angles would add up to 180, I could find a missing measurement. I would know that they would be the same. Because I do 180 subtract the 2 angles, I would know. So anyways, if angle S is congruent to angle M and angle R is congruent to angle L, then the 2 triangles are similar. So that's how we write the triangle similarity statement. Triangle SRT is similar to triangle MLP. So again, the order of the letters matter, just like they do with congruence. S and M are congruent or corresponding. For the angles are congruent. R and L are corresponding. T and P are corresponding. So you can see over here in the diagram how they match up. Okay, so that's one of our, it's actually a postulate, but it's one of the ways we can prove triangles are similar. Here is the next one. Okay, I took the rest of the page. So this is side, angle, side, but remember we're talking similarity, not congruent triangles. So side, angle, side. So it says if an angle of one triangle is congruent to an angle of a second triangle, and the 2 sides that include those angles are proportional, then the triangles are similar. So it's side, angle, side. The angles are congruent, and then the sides are proportional. The sides are not equal, they're not congruent, but they are proportional. So in this example, we have a congruent angle. One angle of one triangle is congruent to the angle of another. In this example, it's angle A and Q. So I'm going to do one arc at A and one arc at Q. So those 2 angles are congruent. And then we have proportional sides. So 2 sides that include those angles are proportional. So again, we've learned about what included angles are. It's the 2 sides that are formed from that angle. So we've got AB right here, and then QR right here. So you can see a proportion is a ratio, or well, we're going to get the proportion, but we have the ratio of two sides. And then we've got, oh, let's choose some more. Let me get a different color. Okay, so AC is right here and QS is right here. So you can see that those are the corresponding sides, and that if you were to divide them, if that proportion was equal, we would know that it is side angle side similarity. If we put numbers in here and it did not come out to be equal, then we would know that they are not similar. So as long as that proportion is equal, whatever AB over QR is and whatever AC over QS is, if it's equal, and we have the one congruent angle, we have side angle side similarity. So remember that that's side angle side similarity, or we could have from up above angle angle similarity. And remember, pause as needed. I'm going to move on though. So pause it if you need to finish copying that. Listen again if you need to. Okay. Okay, so here is the next part. Remember name and date. Remember guys, 3 questions per page. So you would need to put a question here, something that relates to the notes over here. Something as simple as, what is the side similarity? You just have to have a question about this, okay? Question over here. So anyways, this is the last way we'll learn today how to prove two triangles are similar. Theorem 61, side similarity, SSS, and then the little wavy line for similar. If the 3 corresponding sides of 2 triangles are proportional, then the triangles are similar. So again, proportional, we're not saying that they're congruent. We have to check the proportion and make sure that they're all equal. So here we have 2 triangles which are clearly not the same size. So I know that they're not congruent. We're proving similarity. So if I can prove that the 3 sides are proportional, like if I get a fraction and I reduce it all the way and it equals that one and it equals that one, then it is similar. We'll do an example below of what that would look like, but just to show you kind of like what this is, I'll just color on top of that. So AB over QR would be right here and here. So if I start with the A triangle on the top, I always have to stay with those sides on the top of the proportions. Otherwise, they get like flipped over. We've got AC and QS, AC, QS. So they have to be the corresponding sides, and then the ratios would all equal each other. This is kind of a similar color, but I think you'll see the difference. So then we have BC over RS. Okay, so that's how you would test side similarity. I would have to know the measurement of all 3 sides of both triangles, and then I just set it up and I reduce every fraction and I check it. And if you're not good at reducing fractions, you can also just divide and see what number you get when you divide. And it might be a decimal, but as long as you get the same number for each one, then you know that they are similar. You would know that it is a triangle similarity. And then again, when you write the similarity statement, be very careful that you have the corresponding angles all lined up. Okay? So now we're going to do some examples. So just to refresh your memory and make sure we know what we're doing, we have 3 ways to show that triangles are similar. We've got angle similarity, where 2 angles are congruent. Side angle side similarity, where 1 angle is congruent, but we have to check the proportion. We have to do the fractions of one side over the other side and the other one over the other one and see if they're equal. So we have to see if they're proportional. And then the other one was this one, side. Okay, so side similarity. Again, we have to check every side with its corresponding side and make sure that they are all proportional. So you will probably be needing a calculator at some point. Okay, so here's our examples. Instead of doing bookwork, I was like, let's just put this in the notes and practice it here. So here's our examples. And this is really similar to, we're having alex.com for today, so it's really similar to what you'll see there. So examples, are the triangles similar? If so, write the congruent statement where you have the, like from up above, like this one. That's the congruency statement, and verify proportional sides. So looking at number 1, go ahead and draw it on your notes. I do see these two sides are the same, so it's an isosceles triangle, and then these two sides are the same. They're not equal. It's one has 6 and one has 8, but I'm just trying to notice how they are corresponding. And then that one with that one. So I do that visually. I don't always color it, but if you like to color it like that, you can. So none of the angles are marked. So it can't be angle, angle. Just to show you guys, I'm thinking, is it angle, angle? Is it side, angle, side similarity? Or is it side, side, side? I have no information about any angles, so it can't be any of the ones with an angle. The only one it could possibly be is the side, side, side. Oops, you can't see that there, side, side, side. Sorry. Okay, so luckily that's right here on my notes. So I'm thinking, okay, I got to do one ratio equal to another equal to another. I'm going to set it up like that. So I have my side AB, which is 6. And then the corresponding side, it could be GE or GF. Since it's isosceles, it doesn't matter. It would be 6/8 either way. And then CB is 6/8. And then the last side is 9/12. So I want you to just notice when I'm setting this up, I have the 3 sides from one triangle all on the top, and then the 3 sides from the other triangle all on the bottom. You have to have it the same triangle on the top, and then the other triangle is on the bottom. If you start switching them and mixing them up, it's going to come out wrong. All right, so anyways, I'm noticing like each fraction I have to reduce. So I hope you remember how to reduce fractions. On this one, I would divide the top and bottom by 2. I'll just show that real quick, lightly. So that would be 3/4. And I'm checking to see if it's equal. If they don't come out equal, then I know something's wrong and they're not similar. Then I've got 6/8. Again, I know it's going to be 3/4. And then 9/12, I divide by the greatest common factor, which is 3. I can divide both by 3. 9 divided by 3 is 3. 12 divided by 3 is 4. And check. Yes, they are all equal. If you are really not good at reducing fractions, you could divide this in a calculator for each one. And if you were to divide 9 divided by 12, 6 divided by 8, they would also all equal 0.75. And as long as you can verify that they are all equal, then that's fine. So yes, it is all proportional sides. So we've got, I'll write it up here, side, side, side similarity. And I'll circle that. There's really nowhere to write this. So I'll write it under here, I guess. Triangle ABC is similar to, so A is kind of like E. And if I go A, B, C, E, G, F, E, G, F. Okay, that's the similarity. Oh, I put congruence. That should be similarity, sorry. Similarity statement. There we go. Okay, that's the similarity statement. Sorry about that. Okay, so I guess that's pretty much it for that one. That's everything. Are they similar? Yes, side, 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 and then the similarity statement. And we verified proportional sides. Okay, here is the next one. Go ahead and copy that down. Let me see. There. Okay. So again, I want to kind of plan it out and see what is given to me. I do have that they both have right angles. All right angles are congruent, so I have one congruent angle. 2 sides are given, so I've got a 6 and a 10. So what I also do when I'm thinking about, like for this one and then this one, the corresponding sides, I see a smaller and a larger number. So over here I see a smaller and a larger, so the larger ones would maybe be corresponding. I have to verify it, so I don't know for sure. So like that. So I'm thinking out of my options I had up here, angle, angle similarity, side, angle, side, and side, side, side. I have two sides and the included angle. It could be side, angle, side, but I have to check. So I'm going to put a question mark. So make sure you're separating your work. Okay. I'm going to move this. Okay. All right, so I'm going to go ahead and check my sides. I have to check if my sides are proportional. So I would do my smaller side on one and the smaller side on the other. So I did smaller side, bigger side, and bigger side. I can tell right away that is not proportional. And I could even tell when it's set up. If it's a 6 and a 6, you'd have to have them be the same and they would actually be congruent. So I can already tell it's no. But just to show you what you would do 6 divided by 6, which is 1 over 1. 10 divided by 8, I would just reduce them. It would be 5 over 4 by dividing by 2. And they are not equal. Not equal, so not similar. So they're not similar at all. It's not side angle side. I would need it to be equal, like how it was up here, how we got 3/4, 3/4, 3/4. Here, 1 over 1 does not equal 5 over 4. So if you ever get something like that, it is not true. It is not similar. Okay, so moving on to the next one. Pause if you need a little time to copy. On this one, notice how the triangles are drawn. They're kind of like joined at point E. And we actually have vertical angles. So don't forget, all vertical angles are congruent. If you ever have vertical angles, you can always mark them. So I'm going to mark my vertical angles are congruent. So if I do that, then I know that this angle over here is also the same. It's also 35. Sorry, that is really bad. 35. Okay, so I've got angle A is 100. Right here, AEZ is 35, REB is 35, and then right here, angle B is 45. So for both of these triangles, since I know two angles, I can always find my third. I can do 180 minus 100, and then minus 35. And I can just do that in the calculator. Over here, I can do 180 minus the two angles I know, so minus 35 and then minus 45. And then I can calculate that and see what I get. So here I end up with 180 minus 100 is 80, minus 35 is 45. So I can write 45 right here. And then over here, 180 minus 35, and then minus 45 gives me 100. So 100 degrees. All right, now that I have that, let's check and see if these triangles are similar. I don't know anything about any of the sides. So it can't be side, side, side similarity or side, angle, side. It could be angle, angle. Angle, angle similarity. In order for it to be angle, angle similarity, I need just two congruent angles. Two congruent angles. So if I'm looking, I've got 100 and 100 and 35 and 35. So I'm good. I actually know that all three angles are congruent. So yes, angle, angle similarity. And then I do want to write my similarity statement. So let me switch to pen so it's darker. Zoom out just a little. Okay, so my triangle on the left, I'm going to call it AEZ, similar to triangle. A is like REB, REB. And again, there's no information about any of the sides, so I can't check if sides are proportional, but it is angle, angle similarity. So I know that the triangles are similar, and if I knew a side, I could say that the other triangle has proportional sides. I would just need to know the scale factor to know what to multiply by. Okay, one more example. Let's slide this down. Okay, so we have this triangle, that's a U, UGA, and then BFE. Again, we're checking for triangle similarity. And I have one angle given, and it's both of them at 70. So I know that they're both congruent right there. One congruent angle, and then we are given two sides, and then the angle is included. So like I said kind of before, I've got a smaller and a larger side. So I'm going to do the smaller side pink, over here the smaller side pink. That's how you can tell which ones are corresponding. And then the larger side, I'm going to do like in green, and the larger side here in green. So that helps me to set up my proportion so I can check it. So it's looking like it's side angle side, but I need to verify that the sides are proportional. So again, the way I do that is I set up a proportion. I only have two sides given, so I'm going to be checking for two sides. I'll put the left side triangle on the top, so 12 for the pink, and then 15 on the bottom. And then here's 16 on the top, and then here 20 on the bottom. And I don't need to be cross multiplying. Remember, I'm just trying to reduce the fractions and see if they are equal. So for this first one, I would divide top and bottom by the greatest common factor, which is 3. Divide the top and bottom by 3. So 12 divided by 3 is 4. 15 divided by 3 is 5. And then on the second ratio, I divide by the greatest common factor, which is 4. 16 divided by 4 is 4. 20 divided by 4 is 5. So you can see, yes, those are equal. So that tells you that the sides are proportional, and it is side angle side. So yes, side angle side similarity. And then I can write my similarity statement. So I can just go UGA. UGA, triangle UGA is similar to triangle. So U is like F. So UGA, FEB. Okay, and so that is the answer. Whoops, let me move that. Okay, I'll zoom it out. Okay, so just make sure you guys finish up with a summary, 3 sentences, and summarize the lesson. Go back to your essential question and answer that. How do I use similarity theorems to find a missing measurement? We were mostly just verifying that triangles are similar. So, and make sure you guys do your math, it's not Math Excel this week, make sure you do your alex.com. It's number 18, just like how these notes are number 18, alex.com is number 18.